Welcome to the first of our pre-calculus video lesson series, and today we're going to be talking about lesson 6-1, which covers the ideas of radian measure. Radians are a method of measuring angles that's different from degrees, and it turns out that it's going to be very useful for us to use radians to measure angles in this chapter and whenever we talk about trig functions. We'll see a little bit why that is this morning. Before we get into that, however, I want to just take a moment to remind you of some of the important ideas about why we're doing these video lessons and how you can make best use of these ideas. So why video? The major reason why we want to do video is we can spend more class time on homework. Rather than having the time that we spend together be devoted to listening to me and then going off on your own and working on homework, it makes more sense to have the time when you're on your own be time that you focus on learning the material and then getting to practice that when we're together and I can give you a little bit more assistance. When we talk about video lessons, the important thing to note here is that you should treat them like a regular class. So what do I mean by that? Well, there are two major components here. One of those is attendance. Even though you don't physically have to be in a particular spot to watch these videos, you do need to make sure that you are on a regular basis watching the videos as assigned. You will quickly fall behind if you are not being responsible for this material. I will do everything I can to make it accessible to you and give you opportunities to watch these. I'll put them on the local server as well as on the internet, but you do need to be watching these. We won't be covering material to the same depth in classroom, rather we'll be practicing, and you will fall behind and struggle if you are not keeping up with the videos. The other thing I would strongly encourage you to do is to take notes. Treat it like a regular class. You should be keeping a set of notes for the material we've discussed. You should be going through things in a normal fashion. So treat it exactly like you would a regular class. Maybe pay a little bit more attention than you would. Stop looking at other people, whatever. Treat it like a regular class, and it will be beneficial. Remember that you can stop the video, you can re-watch the video, you can go over parts that were confusing. I also encourage you to stop when we start an example in the video. You should stop. See if you can do the problem yourself, and then resume the video to check your work. Okay, well, let's go ahead and now focus on radian measure. And to start with this, we'll just review for a moment the fact that in Chapter 5 we introduced the idea of degrees, minutes, and seconds. Degrees, minutes, and seconds is a historical unit. This is a historical unit. We got this from a particular culture. The Babylonians originally came up with this measure of units. We see this when we talk about angles in degrees, minutes, and seconds. We also see this when we talk about time, hours, minutes, and seconds. So this is a historical unit from the Babylonians and is not necessarily the most convenient way to measure angles. In fact, there are several other ways of measuring angles. They're not as common, but the military, for example, has their own system of units that they used at one time, and there are other divisions as well. You might think that dividing the circle into 100 units versus 360 may be more useful. But today we're going to talk a little bit about radians. And the important thing about radians, the important thing to note, is that it is the most natural unit. It's not going to seem that way today because you're so used to talking about things in terms of degrees, minutes, and seconds that to talk about angles in a different way is going to seem really weird. However, it is the natural unit of angle, and we know this. Okay, and this is the thing that will make you hopefully a little bit happier. We know that this is the natural unit because it makes equations simple. Anytime we can make an equation simple, we have found something useful. So radians are a unit we can use to measure angles. When we do, many things become simplified. Okay, we'll see this throughout the next couple of chapters, that radians make things a little bit simpler. So let's talk about where the unit of radians comes from. To do that, we need to start by taking a look at a circle. So let's get a circle up here. And if this is our circle, notice that we can define the radius of our circle. The radius of our circle is simply the line segment that goes from the center to the outside edge. And this is our radius r. If we were to take this radius and say make it out of a paper clip and bend this into the curve of our circle, we could take our radius r and we could fit it to the edge of our circle. So this is one radius of what we will call arc length. If we were to walk the length of this arc, that would be exactly one radius long. If we set this up so that we have this one radius of arc length here, it turns out that the angle that we have made from those two endpoints, this particular angle right here, happens to be 1 radian. And this, in fact, is the definition of the radian. The radian is the angle formed by the arc that is subtended, so this arc right here, this arc that is subtended by 1 radius of the circle. Okay? So it's a very natural unit to use in the sense that the measuring unit actually comes from the circle itself. Now, an interesting thing here is if we look at several circles together, if we look at several concentric circles, and I will just sketch this out here. If we look at several concentric circles, if we look at 1 radian in the larger circle, that gives us 1 radian in the smaller circle and 1 radian in the smallest circle. So this is a consistent way of measuring, and 1 radian of angle measure will be the same size angle regardless of the circle we're talking about, because the circle changes size as well. So 1 radian is the angle subtended by 1 radian of arc length. So it's a very natural unit to use in the sense that our measuring unit is right there in the circle. That's the good news. What's the bad news? Well, there's always bad news in math. The bad news here turns out to be the number of radians there are in one circle. It turns out that when we look at a circle and we try to start putting radii on the outside edge, so if this is our radius, if we go to start putting radii in the outside edge, it turns out that we do not get a whole number of them. It turns out we're not able to fit a nice whole number of radiuses here in our circle. In fact, it turns out that it takes roughly 6.28 radii to make one complete circle. It's not exactly 6.2 radii. In fact, it's a number that goes on forever and ever. It's rather long number and complicated number. People are very interested in this number. So this is the bad news, that we do not get exactly an even number. It doesn't take, for example, 6 or 7 or 5 radii to go all the way around the circle. It turns out to take about 6.28. And so mathematicians, to make this number a little easier, have just given it a label. We call this number 2 pi. And we say that 2 pi radii will fit on the edge of a circle. So if you've ever really wondered where the number pi comes from, this is precisely the place. 2 pi here is a measure of angle, 2 pi radians. Okay, 2 pi radii, 2 pi radians is the angle. So now we're getting somewhere. Now we can start to make connections between radians and degrees. So we can go back to something we're a little bit more familiar with. So let's take a look at how this works. So we know that one complete rotation is 360 degrees. We also now know that it is 2 pi radians. So that must mean that these two objects are equal. 360 degrees is the same as 2 pi radians. So what that means for us is that we can do a conversion now, and we can talk about how these two things are related. And in fact, what we can do is we can say that 1 radian is equal to roughly 57.3 degrees. So 1 radian, 57.3 degrees. This is a useful conversion. There are other ways to convert as well. In fact, let's take a look at an example. How many degrees are in 11.3 radians? Okay. One of the problems we have with radians, and one of the problems you'll have throughout this class, is that we're not necessarily used to thinking in terms of radians. So you don't have a good gut feeling about what radians are. But there's a fairly straightforward way of doing our conversions. So let's take a look at this. We'd like to take 11.3 radians, and we would like to convert that into degrees. To do that, we simply have to multiply by a factor that will do the conversion for us, a unitary factor where the numerator and denominator are the same. Since we want to cancel out radians from the numerator, we need to have radians in the denominator of our expression, and since we have degrees as the result we want to have, we need to have that in the numerator. So we simply have to put in what these things are equal to. And we know that 360 degrees and 2 pi radians are the same. So to convert our 11.3 radians, we simply multiply by 360 and divide by 2 pi. When we do that, we find that we end up with a number of roughly 647 degrees. 648 degrees if we round to the nearest degree. So this is a very straightforward way to do things, and just for your own knowledge and just for your own use, some of the common angles that we're used to seeing in trigonometry can be expressed pretty easily in radians. So if we make a little chart here, talk about degrees and radians, clearly 0 degrees is the same as 0 radians. 30 degrees will be pi over 6 radians. 45 degrees is pi divided by 4 radians. 60 degrees is pi over 3 radians. 90 degrees is pi over 2 radians. So this is a quick conversion between some of the common angles that we have been working with trig functions and degrees, converting those into radians.